Hey y'all, Ms. Harper here for our Solving Systems by Elimination notes, our third method of solving systems. So at this point, you should know how to solve systems by graphing, solving for y, graphing them on a coordinate plane, finding their point of intersection, substitution where we isolate a variable, plug it into our second equation, and now elimination. You should be taking these notes by hand on your own paper. You may need to pause this video to write down these steps and notes here on the right hand side. Sorry, my handwriting is very poor coming back to school. Alright, so again, pause the note video as you need to and write down the system. So the first thing it says is we need variables with opposite coefficients. So think about the number attached to a variable. So for example, if I had the coefficient 5, the opposite of that would be -5, and the opposite of -10 would be +10. So looking at the system of equations, alright, so and then second to that, they must be in standard form. Alright, that's where we have our x and y on the same side. Alright, so looking here, we have both of those things, so we can move forward with our next step. They're both in standard form, and right here we have a -2y and a +2y. So what we're going to do is crazy looking, but we're going to draw a line here, and we're going to actually add these two equations together, or combine like terms. So if I have -2x and -3x, that means a total of -5x. Alright, our y's here will be eliminated because -2y and +2y is 0y, and this is going to equal to a -20. And then from here we finish solving for our x variable, and I get x is equal to +4. Once you figured out the answer to one of your variables, same thing to substitution, is we're going to take it and plug it back into one of our original equations. Now again, it doesn't matter which one you plug it into. You can plug it in here or here. Let's just say for funsies, I'm going to plug it into the second one. So I have -3x plus 2y equals -14, but now I know what the value of x is. It's 4. So I'm going to plug in or substitute that 4 in and finish solving this for y. So I have -12 plus 2y equals -14. Add the 12 to the opposite side. Drop down my 2y. I have 2y equals -2. Divide both sides by 2, and we would get y equals -1. Alright, remember it's always important before you decide to box your final answer, take the time to plug it in. Alright, so let's see, this is already set up for us. So all I did is I plugged in the x and the y values that I got into my calculator. So I have -2 times x minus 2 times y, and it should equal -6. Alright, and then I did the same thing for my second equation, -3 times 4. Plus 2 times -1, and I got -14. Alright, so in the event you plug in your x and y values and you don't get those answers on the right hand side over here, then you need to go back and check your steps. So now that I've checked myself, I'm going to go ahead and box my final answer. Remember, we always list these as x, y coordinates, so my first value would be 4 when y is -1, and this would be my final answer. Alright, let's move on to our next example. Alright, this is one for you to try. Alright, so go ahead and write down the system. You try it out. Alright, you should notice right here, it's in standard form, and we do have opposite coefficients with one of our variables. So our x's are going to cancel out, and this one ends up really nice. So pause the video, try this example on your own, and then you can resume the video. Alright, so if you're picking back up with me, you should have paused and tried this problem out on your own. You should have ended up with the solution 5, 0. So here it canceled out really nicely. 2y and a -y is 1y, and then our 15's canceled out. Take that 0, plug it into y, and I got x equals 5. And before I boxed my final answer, I went ahead and plugged those in. -3 times x minus y, and it did equal -15. 3 times x plus 2 times y, and that one equaled +15. Check yourself before you wreck yourself. Alright, so sometimes we get problems like this. Again, pause the video, write down these extra notes right over here. This is what we're going to call a forced elimination, where we have to modify one or both of our equations by multiplying in order to make those opposite coefficients. Alright, so pause the video, write that down, alright, and then let's look at the system. So there's a couple different ways to approach this. So as you can see, they're both in standard form, so that's great. But if I look at my x's and I look at my y's, none of them are actually going to cancel out. So this is where we have to force one to cancel. or force one to eliminate. There's lots of ways to do it. So looking at my x's, what could I multiply that top equation by so that it would cancel out with a negative 8x? Well, in order for it to cancel with a negative 8, I would need this to be a positive 8. So I can multiply the whole top by negative 8, because a negative times a negative would give me a positive 8 there. So that's one option. Your other option would be to look at your y's. It's kind of easier this way because we already have a positive and a negative here with our y values. What's the relationship between 9 and 18? Well, if I multiply this whole top one by 2, that would make that a negative 18y and then cancel out with the positive 18y. So I'm going to go ahead and do that one. Now be careful whenever you decide that. You have to distribute it to all three parts of your equation so it doesn't change or alter the actual value of your equation. We're just increasing it by a common multiple. So 2 times negative x is negative 2x. 2 times negative 9y is negative 18y. And then 2 times 11 is 22. So now I'm looking at these two equations to do my elimination. Alright, so now I just forced my elimination. The y's are going to cancel out. Whenever I combine my x's, negative 8 plus negative 2 is a negative 10x. And 22 and negative 2 is 20. Divide both sides by negative 10, and we get x is equal to negative 2. Again, whenever you found one of your variables, you need to take it and plug it back into one of your original equations and for x. Alright, it doesn't matter which one you do. I'm going to go ahead and take a look at the first one. So our equation is negative x minus 9y equals 11. Alright, so I'm going to insert, using my parentheses, my x value. My x value is a negative 2. Alright, now you got to be careful here. What do we call this? A negative and a negative. Well, you could think of this like a negative 1, or we call those double negatives, and that will become a positive 2. I'm going to kind of take this over here. So I have 2 minus 9y equals 11. I'm going to subtract the 2 from both sides. I have negative 9y equals a positive 9. Divide both sides by negative 9, and we get y equals negative 1. Again, take the extra time to plug it into your calculator to check your answer. My final answer here would be negative 2, negative 1. Alright, let's check out another one. Alright, sometimes we have to do what I would call like a double forced elimination. Alright, so if we look at these, we had an easy opportunity in the last one where we could multiply a 9 by a 2 and get to 18. But if we look at these numbers, there's nothing I can multiply 2 by to get to 7. And there's nothing I can multiply negative 7 by to get to negative 12 to cancel out. So this is one where we have to multiply both of our equations. Okay, so I would trend towards the smaller numbers. So I'm going to look at the x's. All right, what number could I multiply? Sorry, I had to pause the video there because I was having some lagging issues with the smartboard. All right, so anyways, let's think about a common multiple that we could get this x to. All right, we have 7 and 2. So think about that for a second. What's a number we could get them both to equal? Hopefully you might be thinking about 14. So if I multiply the top by 2 and the bottom by 7, the top one will give me a negative 14x and the bottom one will give me a positive 14x. And then those two variables will eliminate one another. So I'm going to go ahead and do that. Remember, you have to distribute this to all three parts as well as this. Okay, so I'm going to end up with two new equations, negative 14x plus 24y equals 56. And 14x minus 49y equals negative 56. Alright, now we combine like terms and add up our two equations. Our x's are eliminated. I'm left with negative 25y equals 0. Divide both sides by negative 25. And you get y equals 0. Okay, whenever we know the value of one of our variables, I'm going to take them and plug them back into one of my originals. I'm going to do it to the second equation. It doesn't matter which one you choose. You should get the same answer either way. So I know what the value of y is. It's 0. So essentially that just disappears. I'm left with 2x equals negative 8. Divide both sides by 2. We get x equals a negative 4. Remember, we list these things as coordinate points when x is -4, y is 0. One last example to look at. Alright, we got a word problem here. So it says write the system of equations for the given situation. Tony bought, that's supposed to say chips. Tony bought some chips for his party. The sour cream and onion chips were $2 a bag. Cheetos were $3 a bag. If he spent $17 on 7 bags of chips, how many of each bag did he purchase? Alright, so some important information is these chips cost $2, these chips cost $3, and he spent $17 on 7 bags. So there's 2 equations embedded in here. One, remember that your money goes with money. We practiced a word problem very similar to this the other day. Alright, so I'm going to do the money part. So I'm going to use S. That's going to represent the sour cream and onion chips, the SCO chips. Really, that's the number of them. And then the Cheetos is going to be the number, or C for Cheetos, the number of Cheetos. Alright, so first one, hopefully you can identify the money one. Alright, it was $2 per each one of sour cream and onion chips, plus $3 for each bag of Cheetos, and he spent a total of $17. Alright, remember that S and C are representing a number of each type of bag of chips or whatever. Alright, so if I said like 5S, that would mean like, if I plugged in a 5 for S, that would represent 5 bags of chips. So we could say S, the total number of sour cream and onion chips, plus the total number of Cheetos, then he bought a total of 7 bags of chips. Alright, so now we have a system of equations and I can do my elimination. Alright, we are both in standard form, so that's good, but we don't have any coefficients, we don't have any opposite coefficients attached to our variables. So I'm going to have to force one. Now there's actually 2 options on this one. Okay, what can we multiply the bottom equation by to get one of those variables to cancel? Well, you have 2 options, right? You could either multiply it by a -2 or a -3, depending on which variable you'd care to choose to eliminate first. I am going to go ahead and do the -2. Alright, again, it doesn't matter either way. So my new equation, I'm going to rewrite the top one. So here's my top equation. And here's going to be my new equation. -2 times S is -2S. -2 times C is -2C. And -2 times 7 is -14. Alright, I eliminated my S variable. I'm left with 1C. 3C minus 2C is 1C. 17 minus 14 is 3. That means he bought 3 bags of Cheetos. So if this man bought 3 bags of Cheetos, how many sour cream and onion bags did he buy? Well, there's a total of 7 of them. So for the sour cream and onion, he bought 4 of those. Alright guys, if you have any questions, come see me in tutorials.